All right, hello Algebra 2. It's the 16th. We're doing Unit 4, lessons 8, 9, and 10, which I know is going to be favorite topic. Logarithms. All right, so don't forget log is the opposite or the inverse of an exponential. And so this first question we got log base 2, 2x minus 8. Which of these would not be in the domain? Which would not work? So there's a problem with logs. You can't take the log of 0, and we can't take the log of a negative number. So like let's just try the first option. Let's put 5 in there. What's log base 2 of 10 minus 8? So that'd be log base 2 of 2. What does that equal to? So I don't know if you remember this, but there's the base. We switch it to an exponential. We say 2 to the x power is equal to 2. Well, that's 2 to the first power, so x would be 1. Now, I did that just as a little review. The whole point is, I'm going to get an output. So this input gives me an output. So this one is in the domain. Works. That one works. Okay. So we're trying to find the one that doesn't work. So I'm just looking for the one that gives me a negative number or 0. So if I plug 2 in there, 2 times 2 is 4. Take away 8. All right, so that's the log of negative 4, log base 2. So like 2 to what power? So let's put x there. So if I try to convert this, 2 to what power gives me negative 4? Well, nothing. There's no such thing. So 2 to any power is not going to give me a negative number. It's always going to be positive. So this is the one that doesn't work, and that's because I can't take the log of a negative number. Okay. 2. If b is greater than 0, what is this equal to? Log base b. So this is that converting thing. Maybe I should write it up here. So how do you go from log world into exponential world? So b to the x, b, the base raised to the answer, is equal to the number. That's how I like to write it. So we're just switching x and y. I could put y there if you like, switching them around. That's what I'm doing here. So log base b, 1 over b cubed, equals what? We don't know. I'm going to convert it. B to the x equals 1 over b cubed. And this is where I say you need to know exponents, because what is this? This is b to the negative 3. So x is negative 3. All right. There are 3 laws of logs. I'm going to write them down here. So multiplication breaks up into addition. And if you buy that one, then you should have no trouble with division becomes subtraction. And the third one, the power rule, log, we don't care what the base is, of a number, I'll put m, raised to some power, that power can go in front. All right, so that's what I'm using on this type of question here. So I'm going to say, all right, division turns into subtraction, log x squared minus log the square root of y. Oh, there's the power rule. That 2 is going to go in front. But this is a power too, you got to recognize it. This is y to the half power. So that power is going to jump in front. So I get 2 log x minus 1/2 log y. Now that is one of the answers over here, but it can get disguised. If you've got a common denominator, this is the same thing. See, 4 over 2, 4 over 2. 2 goes into 4, 2 times. And there's a 1 here, minus 1/2 log y. So this is the right answer, but it's kind of in disguise. All right, we're just going to keep using those laws of logs for most of the lesson here. All right, log base b5 equals 1.2. What is log boy? Okay, so 100. How is 5 related to 125? That's what you got to figure out. Log base b of 125. That's the same thing as 5 to the 3rd power. 5 to the 3rd power is 125. And I'm going to take that 3, move it in front. And they told me this was 1.2. So now it's going to be 3 times 1.2, which is 3.6. Notice I'm not using my calculator. Log base B 36. Which one's not equivalent? Not equivalent. All right. This is still the laws of logs. So like, for example, subtraction, I could put it together and say this is 72 over 2, which is 36. So that one is equivalent. I don't know. We could use the third law of logs, put the 6 in here. This is log base B. 2 to the 6 power. What is 2 to the 6 power? I gotta think myself. 2 to the 6 power is, now let's use the calculator on that one. 2 raised to, clear. 2 raised to the 6 power is 64. So this is 64, not 36. So this one is not equivalent. The other ones would be if I checked them. Solve without your calculator. Without the calculator, show work. Okay. So I'm going to use that conversion thing. I'm going to say, hey, the base is 4, and I'm going to switch these around. X to the 16th. So I went from log world into exponential world, and now I'm going to solve this. They both have base 2 in common. This is 2 to the 2x, and this is 2 to the 4th. I can drop my 2's. This is what we did in the last lesson. And now I divide by 2, I get x equals 2. Boom. 7 is the base, and I'm going to switch these around. 7 raised to the negative 2 is equal to x. Well, what is 7 to the negative 2? It's 1 over 7 squared, which is 1 over 49. Done. 3 is the base. Switch these around to the 4th power equals 2x plus 7. What is 3 to the 4th power? 3 raised to the 4th power, 81. 2x plus 7, take away 7, take away 7. 74. Right. Divide by 2. What's half of 74? I should know that. 35. 37. Again, you should try one of these. Don't just look at me doing it. Try it yourself. And oh, you go. Oh, the base is 9, and we're going to switch these around. X goes on top. 1 over 27 goes here. Hopefully you recognize this. You say, hey, they're both base 3. That's 3 squared. This is 3 to the negative 3rd. Drop my 3's. 2x equals negative 3. Divide by 2. X equals negative 3 halves. All right. For some base, it is known that the base, when you do 5, you get 1.28. When you do 2, you get 0.55. What would you get for, what would 40 be? So somehow you have to use the number 5 and the number 2. 5 and 2 have to go into 40. So think about this. How could you break 40 up? Isn't 40, 5 goes in there, 5 times 8. But isn't 8 a power of 2? So couldn't you say this is 5 times 2 to the 3rd power? So the trick is to just use 5 and 2. Break it down, you just use 5 and 2. All right, now I'm going to use my laws of logs. Multiplication breaks up into addition. And then I'm going to use the power rule. Put that in front. And then I know this is 1.28, 1.28, and this is 0.55. So bust out the calculator. .93. So, all right. Use laws of logs to evaluate each of these. No numbers this time, just x and y. So every time I see log base 3, I'm going to say that's x. When I see log base B8, I'm going to say y. I got to use my 3 laws of logs that we've already just reviewed. So I know division turns into subtraction. All right, I got 8. What about this one? Well, that's 3 squared. And that square, just going to go in front there. So I'm going to get 2 times log base, that's the 3 turns into an x, and that turns into y. So my final answer, 2x minus y. Done. Okay. So maybe you want to try this one on your own and then watch me do it, but I'm just going to go right ahead and do it. So I know this is going to turn into subtraction again. (64), isn't that 8 squared? That's 8 squared. That's all. So I'm going to change that to 8 squared. And then I'm going to take this 2, just like I did up here. I'm going to go in front. I'm going to get 2 log base b 8 minus the log of 3. That is y and that is x. So this time I get 2y minus x. Kind of good that they're very similar, because these are very similar problems. All right, I get to 24, and I go, all right, what's 24? How is that related to 3 and 8? 3 and 8. Oh, 3 times 8 is 24. So I'm going to say this is 3 times 8. And multiplication breaks up into addition. So I'm going to get y. No, sorry, that's x and that's y. So I'm going to get x plus y. Done. All right, toughest one, the cube root of 9. All right, well, you should know cube root means to the 1/3 power, 1/3 power. I'm gonna move that 1/3 in the front. 1/3 the log, but 9, I don't have 9, but I know 9 is 3 squared. We already did that trick. Oh, take that 2, move it in the front. So what am I gonna get? 2/3 the log of 3. Keep forgetting to put that little b there. So I got 2/3 of log base b of 3. Log base b of 3 is x. So I get 2/3 x. Done. All right. So you got very similar questions to do on the independent work. A lot of work to be shown here on this second page, right? First page should be just the multiple choice, but you should be showing me the work on these. All right. Be safe.